We're going to go live in just a second. Oh, I think we're live now. Is that right?
Yeah.
Okay, awesome. Awesome, okay. Any questions? Okay, so let's keep going. So we have A1 is equal to A, and then A2 would mean that we're going to plug in 2 as n. So we have A 2 over 2, B using the formula, and that gives us A1B. So that's A, B. And then we keep going, A3. So 3 is odd, so we plug into the second formula. We get A3 minus 1 over 2. So that's still A. We have A here from the formula, and we have A1A. That gives us AA for A3. And then A4, we keep going. It becomes A2B. And we have A2 here. Oh, shoot. What happened? Okay, let me just rewrite this really quick. I don't know what happened. So we have A2 here as AB, and then we add B at the end. And then A5 is equal to A5 minus 1 over 2A. And we have A2A. So we have ABA. We keep going. A6 is equal to A3. B. What? Why does this keep happening? Very confused with the technical difficulties.
Can't I go back?
Yeah, I don't know why I can't do that. It's weird. Didn't have this problem yesterday when I was doing this problem, but anyways. How about we just we have A3AB for A6, which gives us A, B. Is that right? Yep. Okay. And then we have A7, and that is also A7 minus 1 over 2, so A3A. So that is A. And then we have A8, which is A4B, and that is A, B, B, B. It happened again.
I think Chris have a question.
Oh, do we have a question? Somebody raised a hand.
Yeah.
Yeah, I just have a quick question.
Go ahead.
Does the order of like A, B matter? Like, do you need to have A's before B's, or is that not a big deal?
Yes, so in this case, it does matter because we've defined them like this. So because we've defined the formulas like this, and the B's and the A's, if you switch them, so like for example, we have, what are the two ones that are similar? So if we have A, B, and A, that wouldn't be the same as A, and B. They would not be the same thing.
Okay, thank you.
So it's a string. Yes, somebody asked. So it's a string. Yes, we're defining these things as strings. Like with words, we cannot swap the orders of the letters and still be the same word. I don't know why this keeps happening, but I think what's very important is to, right here, we have A8 is AB. So let's actually do this one. A4, B, which gives us A, B, B, B. So this one is very important to what we have to do later on, but I'm just gonna leave it here. So then does everyone understand how this process works? Any questions about this process? Okay, no question, then we're gonna keep going. So then we move to part B of this problem, which says use the result from part A to determine A17 and A21. So, okay, there's another one that we need, which is A10. It's not recording for some reason. I have to figure this out today. So A8 is ABBB, and A10 is ABAB. I'm gonna write these here so we remember. And then, so how do we find A17 and A21? Any ideas? Same thing, right? We're gonna plug in 17 as n and 21 as n. So A17 is equal to A17 minus 1 over 2A, since 17 is odd. So we have A8A. And based on our calculation before, A8 is ABBB, and we add an A at the end. So that's A17. And then A21 is A21 minus 1 over 2A. Again, 21 is an odd number. So we have A10A. So that gives us AB. This is A10, and then A at the end. Make sense? Oh, I think it's because I need to save it or something. But anyway, that's fine. So suppose we already know A315 is this long string. Give us the value of A630 and A631. So we're going to do the same exact thing as before. A630 is A630 over 2B. That gives us A315B. Since 630 is an even number, we have B at the end. And we basically plug in this long string over here into here, ABB, AAA, BAA. And then we have B at the end. So we're going to do the same thing for A631, which is A631 minus 1 over 2A. And that also gives us A315A. So it's basically the same string right here, but we have an A at the end. So A, B, B, A, B, A. Save. Okay, I think that worked. Any questions for the first problem? going then. So for the second problem, it's about sequences. So we have a sequence 3, 6, 9, 12, 15. This shouldn't be too hard. Determine the next number in the sequence. Any ideas? I think someone asked, could we find the closed formula? Yes, 18. I see lots of answers. That's good. So it says, could we find the closed form for the previous one? You probably could, actually. You probably could, but the problem is that because there are no numbers, it would be hard to express it. Like we're not, this isn't a sequence, right? This is a string. So there are definitely rules around them. We can come back to this question if we have a little more time. So if we go back here, I see lots of answers. Could we treat it kind of like binary? You can try to convert it into numbers somehow, I guess. I haven't thought much about it. We can let's come back to this question if we have a little more time, and then we'll think more about it. But yes, the sequence is 18, and that's great. So we have 18 here. Give a closed form formula. How do we do this? Closed form formula. We have to see, we have 3, 6, 9, 12, and 15. So the closed form formula is based on its own positions. Yes, somebody said 3. Yes. Very good. Yes, I see your answers. We have 1, 2. So their positions are 1, 2, 3, 4, 5. So we can clearly see 3 is equal to 3 times 1, 3 times 2, 3 times 3, so on. So then we have an is equal to 3n. And then how do we give a recursive formula? Yes, very good. I see lots of answers. So we start with a1 is equal to 3, right? So that's where we start with. And then after that, we can see that 3 plus 3 is 6, plus 3 plus 3 is 9, and then plus 3 is 12, and plus 3 is 15. So we always have an is equal to an minus 1 plus 3. So in our recitations, our professors introduced this method, which is what they did was we have the closed form formula, which is an is equal to 3n. So we want the recursive formula to look something like an is equal to something an minus 1 plus something else. So we have these two boxes. If you've done the pre-lecture quizzes or problem sets, like you would have seen something like this. So how do we convert the closed form formula to the recursive formula? We want to somehow introduce this an minus 1 term into the formula. So what we do is we try to plug in n minus 1 here as n. So we have an minus 1 is equal to 3 n minus 1. We basically plug in n minus 1 here as well. So we have an minus 1 is equal to 3n minus 3. And then we see that the 3n is basically an. So we have an minus 1 is equal to an minus 3. And that gives us, so then we have to move this minus 3 to the other side, or just basically add 3 on both sides. So we have an minus 1 plus 3 is equal to an. So here we've got the same formula. One is just by eyeballing how, like, what's the difference between terms, and the other one is an actual systematic way of doing this. So what I would normally do is, if you want to just like try it, do like trial and error type of thing, I would just kind of multiply like integers here. So like 2 times an minus 1, 3 times an minus 1. If 1 times an minus 1 doesn't give you an integer right here, what I would do is to plug in a 2 and a 3 and a 4 and just try it a few times and trial and error. And maybe one of them would give us an integer here in the second box. But then this is a much more systematic way of finding it. This right here. Yeah. They should both work. Okay, we are, oh, any questions so far? No question? Anyone said something in the chat? Oh. So we have this one problem on logic. Suppose you meet 3 people, A, B, and C on an island. Let P represent the statement A is truthful. Let Q represent the statement B is truthful. Let R represent the statement C is truthful. Wait, actually, there is a question. I think it says, is there a way to find closed from recursive? Yes, actually, that is a good question. Actually, yeah, let me do that really quick since we do have time. So if we have the recursive formula, let's say if we have an is equal to an minus 1 plus 3. So what we want to do is to kind of look at the numbers that we have and then so write out the terms and then try to find a closed form formula. So we have this as the recursive formula. So then we have 3 as the first one. So that we basically have 6 is equal to 3 plus 3. And then we have 9 is equal to 3 plus 3 plus 3. And this is our 6, right? So we basically substitute. So, okay, let's write this again. It's probably not so clear. But 9 is equal to 6 plus 3, right? So at using our recursive formula, we have 9 is equal to 6 plus 3. So we substitute this 6 using the 3 plus 3. So we have 3 plus 3 plus 3. And then we have 12 is equal to 9 plus 3 using the recursive formula. But then this is continues to be 3 plus 3 plus 3 plus 3, substituting this 3 plus 3 plus 3 here as 9. So then we already see a pattern here. This is equal to 2 times 3. This is like 3 times 3, and this is 4 times 3. So sometimes it might take a little more time than just 3 terms. This is just an easier one, but generally using this, you can find, you can basically use the recursive formula and then systematically find a closed form formula just by substituting it one after another. Okay, let's go back to this problem. So we have P, Q, and R representing each of the person being truthful. So how do we represent the following statements? A is lying and B or C is truthful. So how do we represent, first of all, A is lying? Not, yes, I see not. Yes, very good. I see the answers in the chat room. So A is lying, oh, whoops, is not P, right? So that represents A is lying. So we have and here. And then we have B or C is truthful. How do we write B or C is truthful? Yes, very good. I see answers in the chat room. Yeah, so we have Q or R. So that gives us the first statement. not P, and Q or R. So I think one important thing is to kind of see how much, how we partition the statement. So in this statement, specifically, we have this first part, which is A is lying, and the second part, which is B or C is truthful. So these are two parts, and we have an and in the middle. So that's why we write not P and Q or R. Right, so someone's asking, why does the or have, because this is two parts of the statement. So B or C is truthful is the second part of the statement. Because would it make sense if we partition to, like, when it comes to, this is like about an English problem, right? So like if we say that A is lying and B, if we stop the sentence there, would it make any sense? We have to stop the sentence after the and, or like before the and, basically, and B or C is truthful. So B or C is truthful is the second part. Yeah. Okay. And then problem B, A and B are lying. How do we write that? Yes, I'm seeing answers. Yeah, it's very good. A and B are lying. So we have not P, which says A is lying. And we also have not Q, which says B is lying. And then the second part of the statement is or A and C are truthful. So we have the second part of the statement, A and C are truthful. How do we write A and C are truthful? So somebody asked the question, can we write not P and Q? So this is the problem. Like right here, this statement is not equivalent to this statement right here. So if you look at one of the rules, I can't remember which one, like the negation rule. So not P and Q is actually equivalent to not P or not Q. Can't write today. So, and that isn't what we want. Like this statement says either A is truthful or B is truthful. So like that is not what we want. We want A and B are both lying. So if we want to say that they're both lying, they both have to be negated. Yeah, and then we continue. We have A and C are truthful. So we have or here, A and C are truthful. So we have P and R. Oh, it's and, it's not or. And R. Exactly two people, or wait, actually somebody asking a question. Any tricks in determining which one that would have been going from word to symbols? I don't understand the question. Any tricks in determining which one that would have been going from words to symbols? So you mean which? Nancy, do you understand the question?
So it's my question.
Okay, yeah, go
Just to explain it. So I thought it was the not in parentheses P and Q as well. Because just going from words like you're saying A and B are lying. So why can't it would make sense to me to just not A and B?
Okay, I understand
Or
your question.
I get that, but it's just like I guess like how the of those two of like what it was, not P and not Q versus not P and Q.
Mhm.
Are there any tricks of like determining that, like so that we don't get mistaken by that?
So from this is how I think about it. I generally would think that so you kind of separate the statement. So you say that A and B are lying. Basically, we can kind of flatten the statement even more to say that A is lying and B is lying. So then we do the same thing for all of these, like for example, like B or C is truthful. We say B is truthful or C is truthful. So then you're not going to get confused. You're always going to be like, so A is lying, and B is lying. So if that's the case, you know A is lying is represented as not P, and B is lying is represented as not Q, and then you put an and in between. So what you want is that you're trying to fit the statement in terms of the representation. So like A is truthful, B is truthful, C is truthful. So you're trying to figure out what they're like, which each of them are doing, like what's their action. So you want to say that A is lying and B is lying instead of A and B are lying.
The way I understand it, that second equation, the not with the P and Q in parentheses, wouldn't that mean more that in the parentheses you're saying P and Q are both truthful, and the not is saying any possibility other than that? So one could be truthful or one could not be truthful, but you want specifically both of them to be lying. So you need to give it to both.
Yes. Yeah, so intuitively, what you want to do is just to say that what is each one of them doing? Like, what is each one of these person, like three, A, B, and C doing? I think that would help you. So for example, if we continue, you would see, so let's say at least two people are telling the truth. So what does that mean? So like, that means that either A is telling the truth or and B is telling the truth. So like either two of them. So we have different combinations, right? So let's just say that if at least two people are telling the truth. So let's say, first of all, A, B, they are telling the truth. How do we write that? A and B are telling the truth. A and B are truthful. So we're gonna write P and Q to represent A, B are truthful. So A is truthful and B is truthful. But then there are other possibilities such as A and C are truthful. So how do we write that? Same thing, right? We're gonna write P and R. So that means A is truthful and C is truthful. So we don't care about what the other person is doing, basically. In these two statements, so A and B are truthful, that doesn't consider what C is doing. C could be lying or could be truthful. Like we don't really care because the statement says at least two people are telling the truth. So the third person can do whatever they want. So then the last possibility is B and C are both truthful. And we don't care about what A is doing. So then we now have Q and R. So these are the three possibilities that we have. So as long as we satisfy one of them, it will be correct. It would satisfy the statement. So that means we're going to put ors in between. So we have P and Q or P and R or Q and R. Make sense? Somebody asked, would P or Q and Q or R also work for C? So P or Q means either A is truthful or B is truthful.
I don't think it's gonna work because if P or Q is truthful, we can like Q can be truthful. And for the second one, Q or R is truthful. Q can also be truthful. That would be Q and Q. So now at least two people are telling the truth. Does that make sense?
Yes. There's another question. Oh, there's another question that says, can we say something like P and Q or R? But then you're not considering the fact that what happens if A is the person who's lying, but B, C are telling the truth. Like this doesn't consider all the possibilities that two people, doesn't matter which two, but two people. So somebody said, what about P and Q and R? P and Q and R. So the thing is, oh,
Yeah.
go ahead. Go ahead.
I think this is included in the like the one like face that P and Q yeah, that one. So it's
Yeah.
only one piece of it.
Yeah, exactly. Because this basically, this right here would be considered as actually like it would be satisfied for example, for this one. Like we have Q and R here, and we don't care what P is doing, right? So P can be lying or P can be not lying. Whichever one, this statement, as long as Q and R, so as long as B and C are truthful, this statement is true.
Yeah.
So then P can be truthful. So like P and Q and R is basically included in either this statement or actually like any of the other as well. We just don't care about what the third person is doing. So can we go really quick to the last problem that we have here, which is at least two people are telling the truth. So how do we write at least two people are telling the truth? So let's say that the first possibility is that A and B are telling the truth and C is lying. How can I write this? C is lying. How do we write this? Any ideas? Yes, I think that person wanted to say P and Q and not R. Yes. A and B and not C. Yep. So we have a P and Q and not R. So then that's the first possibility. So what about A and C are truthful and B is lying? A and C are truthful and B is lying. Yes, I see questions. Just switch out the letters. Yes, you do just switch out the letters. So we have P and R. Oh, P and R and not Q. Yep. And the last possibility is B and C are telling the truth and A is lying. So we do the same thing here. So we have Q and R and not P. These are the three possibilities that we have. So then if we satisfy any one of them, it would be fine. So it would satisfy the whole statement. So we write or in the middle. These ors look like r's. Oh my God. Okay. Better. So someone asked, do you need 3 of them to fully answer the question? Yes, you need all 3 possibilities. You need to consider all the possibilities, because let's say if we only have these 2 right here, it would be problematic when, you know, B and C are truthful and A is lying. It doesn't satisfy either one of these, but still it is part of the, like, it satisfies the statement. Exactly 2 people are lying. Exactly two people are telling the truth. So you definitely need all the possibilities. You have to consider all of them when you write down these. But then this kind of goes back to what I was saying. It's like you have to think about what exactly each one of them are doing. So if you just think about a statement, exactly 2 people are telling the truth. Like you wouldn't be able to write down the statement correctly. But if you think, okay, what does it mean by exactly 2 people are telling the truth? That means, let's say A is truthful, B is truthful, and C is lying. So that's one possibility. So you think about what each one of them are doing, and then you write the statement down. How much time do we have left? Do we have like 10 minutes?
Yeah.
Oh, okay. So that is actually the last problem that we have, but do you guys have any questions about recitation or anything? If actually give me a second. If not, I do have a problem that I was thinking that we could go over.
Oh, just to answer for the first one, someone asking like, can we use binary to represent the AB one?
Oh yeah, sure.
Yeah, yes, we
Go
can.
ahead.
Use 1 to represent A and 0 to represent B. And the string will become just the binary sequence of that number. Yeah.
So what you're saying is that, for example, if A is
Yeah,
0, B is 1, so
no,
this would be,
if A is 1 and B is 0.
A is 1 and B is 0. So for example, this would we have 1 0 0 1 1 1 0 1 1.
Yeah, that would be just the binary sequence of 3, 15.
And would it be possible to find a closed formed solution for this, since this is actually represented?
I don't think you can use like a closed formula.
Yeah, the problem is just it is a string. The moment you put it into binary, I mean, unless you're very equipped at doing base 2 calculations, you might be able to, but I'm not good at doing that. Yeah.
I think someone is asking a question in the chat, like for the pre-lecture quiz, what concepts should we go over?
They're basically the same things as this, and then you have 2 tries.
I haven't looked at the lecture quiz.
Yeah, so a lot of them are like finding closed form solutions, finding like just very similar to these problems, and then you just need to fill in the boxes on Canvas, and then they're very similar things. There's really nothing new that's like really hard on the pre-lecture quizzes. We're calling them problem sets now, so I think that would reduce the stress.
Yeah.
On these quizzes. So I think, yeah, somebody says that I don't think closed form is really possible because we need to know the order which B, A and B comes. So that's when somebody asks, like, can we put them into binary? Like, I think when they become numbers, we might be able to find some patterns, but the problem is that you have to be able to do math in base 2. And I can't do math in base 2.
Someone is asking, will the slides be posted with the work on Canvas? Did Bay said she gonna post it or?
So you mean these slides, discussion slides? I think we're going to post these slides, right? I think so. Yeah, I'm pretty sure we're gonna post the slides, and I'm gonna go back and add the stuff that were deleted, and then we can post these slides on Canvas under, I think, modules or something. I can't remember.
Yeah.
Some sequence problems require finding an easier pattern first and then using that to solve the given sequence. What do you mean an easier pattern first and then use that to solve? Do you want to unmute yourself? Just like talk.
Is it like 2 sequences?
Sorry, I was trying to figure out how to do it. So like example 5 in part 1.2 gives the sequence 5, 7, 9, 11, 13. And then it recommends breaking that down to a simpler sequence like 2, 4, 6, 8, and using that to kind of figure out the first pattern that you're actually trying to solve. I'm just, sorry, I don't have the like clearest question, but it doesn't totally make sense how they're using that to take a more simple sequence and kind of crack the harder one.
You recommend, in this case, it has the easy closed form and the same recursive. Yeah, that's not a very systematic way of doing it. That's very interesting too. The thing is, like, you might not be able to find something like that, like at least not intuitively just like immediately be able to find an easier sequence that is very similar to the one that you have. That's why, like, I wouldn't recommend doing it this way. Like, I would honestly just recommend trying to find the differences between the terms and see how that works out, and then do some trial and error for a little bit and see how that works for you. And then the systematic ways are, you know, for this one specifically, it would be actually very similar to what we talked about, like 5, 7, 11, 9, 11, 13. So if you want to find a closed form, so you already know that this is like +2, +2, +2, right? So then you already know the recursor formula is an is equal to an minus 1 + 2. So then how do you find the closed form formula? You do the same thing. So you have 7 is equal to 5 + 2. 9 is equal to 7 + 2, which is 5 + 2 + 2. Oh, that's not 2 + 2. And then you have 11. 11 is equal to 9 + 2, which is 5 + 2 + 2 + 2. So right here, you can already see this is equal to 5 + 2 times 1. This is equal to 5 + 2 times 2. This is equal to 5 + 2 times 3, right? So you can see the pattern like this. So I would say this is the more systematic way of doing it. Like, if you like, the point they're trying to make is that this is similar to 2, 4, 6, 8, 10, but this is a simple sequence, right? You might not be able to find something like this immediately when you have a more complicated sequence. Then you would be confused and not know how to proceed. So they're not just intuitive guess and checks. This is just something that you can, that's something that you can do, but this method that we're introducing and the method that the professors introduced to go from one to the other, you know, to go from the recursive to closed form and from closed form to recursive, these are the systematic way of finding them. Generally, I would say one of them would be easier to find than another. So like sometimes like the closed form is easy to find, sometimes the recursive form is easy to find. So you at least now know when you find one of them, you can systematically find the other one. Yeah, so we always want to, we always want to provide. So like A1, especially for recursive formulas, you always, for recursive formulas, you should write something like A1 is equal to 5, and then AN is equal to AN minus 1 plus 2, like something like this. This is a recursive, this is like a complete recursive formula. And then generally you don't have to write this. You don't have to write where you start with the closed form formula, because you always know n is equal to 1 to start with for the closed form formula. We have 1 more minute. Any last minute questions? Any comments from Nancy?
Nope.
Okay.
I think it's time.
Yep.
Because all the discussion section are used the same link, right?
Yeah.
The others just been coming.
Yeah, there's one more question. When developing a recursive formula from the limited sequence, can an answer be wrong even if it produced the limited sequence? Yes, the answer can be wrong if it produces only the first three terms of the sequence and it doesn't produce the rest of them. If that's what you're asking. Like if you have, let's say, five numbers in the sequence and you can produce the first 5, but you can't produce the rest of the sequence, then the formula is wrong. Okay, we're gonna stop here. And thank you for everyone that participated. I'm happy that so many people actually answered in the chat room. And have a good one, everyone. I'm gonna stop streaming now.